Awesome. Thanks for taking that pause while we continue finishing up this lesson. So taking a look, we wanted to know, is this relationship proportional? Remember, there's a couple different ways we can talk about this. We can use the graph, table, or the equation. Please make sure in your response you said which representation you're using for your explanation. So if you use the graph is linear and includes the origin. That's what makes a proportional relationship. If you're using the table has a constant ratio of y over x, which is equal to the constant proportionality, which is your unit rate, which is your slope, and your constant rate of change. If you're talking about the equation relates x to y only using multiplication. Great job. Let's go through slide 27. 27 was asking you to draw a picture to represent the first four stages of our relationship. Remember, now we're looking at the area of a square as a function of the side length. So we're looking at the area of the square as a function of the side length. So we have an area of 9 with side length 3 at stage 3 and an area of 16 with a side length of 4 at stage 4. Now when we're looking at the area of a square as a function of the side length, we notice that when we fill in our table here, I use stages 1 through 5, that our relationship, and you might need to zoom in or out on your graph to be able to see all your data points, our relationship is not following a linear pattern anymore. We're increasing at an increasing rate, meaning every stage we increase more than the previous increase. Slide 29. Taking a look at slide 29, when we wrote this equation, we can see in our equation that we have an exponent of 2. Again, making us see that our relationship is not going to be linear because we have a variable raised to a second power. Slide 30. Would this graph pass through the point 8, 64? Of course it would. A square with a side length of 8 units, which is represented by the x value, would have an area of 64 square units, represented by the y value. Slide 31, consider the area of the square as a function of the side length. The point 864 represents a square with side length 8 units and has an area of 64 units. So I would like you to you listed a couple more ordered pairs that the graph would pass through. 981, 10 100, 11 121, 12 144, and whatever we have x, and then you're going to have x raised to the second power. Awesome. Let's keep going. If we wanted to know if this is a linear function, this function is not linear based on the graph, and we can say the graph is increasing at an increasing rate, and there is not a constant rate of change or slope. Again, we're noticing that the graph is not linear. Let's keep going. Taking a look at the table, is this table represent a linear function? No, there's not a constant first difference in the table. Let's be a little more specific in the table of values. Oops. You can always go back and edit your responses to make them better. Slide 35. Here we notice that the equation, again, is not representing a linear function. There's a variable being squared. This is not a one-dimensional or linear relationship. This equation cannot be written in slope-intercept form, y equals mx plus b. So please make sure you're explaining in more than one way why this equation is not a linear function. Okay, 36 through 38 have to do with Mr. Cortez. I'd like you to finish slides 36 through 38. Slides 39 through 41 has to do with a tennis tournament. Ace. And 42 and 43 have to do with buying a printer. So I'd like you to finish up the lesson. Please pause the video for about 10 minutes so students can finish up the lesson, and then we'll go over the last questions. Thank you. Okay, let's go over our last slides. So independent and dependent variable, please join me on slide 36. Boys and girls, come on, please join me on slide 36. Thank you. Independent variable is the hours driven and dependent is miles traveled. Please make sure you have units here. You don't just have time driven, you don't have distance traveled. Wonderful. Slide 27. Yes! Time versus distance can be modeled by a linear function. And since we're given a table here, there is a constant first difference of 45 in the table. So yes, time versus distance can be modeled by a linear equation, and make sure you filled in our table correctly. Awesome. Slide 38. Taking a look, how fast is he driving? Mr. Cortez is traveling at a constant rate of 45 miles per hour. Make sure you have that word constant rate in here so we can describe this relationship as being linear. Wonderful. So when we're taking a look at our tennis tournament, we start with 128 players, and after round 1, there's 64 players left. Because it's really important to talk about after a round how many players there are left. So the independent is round number completed, and dependent is number of tennis players remaining after that round. And this is really important because at round 1, there's not 128 players. After round 1, there's 64 players. So we have to be really specific here. So I said dependent is the number of tennis players remaining. It's also important we know it's how many is remaining, not how many have been eliminated. And independent is the round number completed, or the one that you're in. So if we take a look at our graph then, stage 0 has 128 players, stage 1 64, stage 2 32, round 3 16, round 4 8 players, round 5 would have 4 players left, round 6 would have 2 players left, and after round 7 is completed, there would be our champion player. And you might need to zoom in or out on your graph to take a look at this, but you'll notice that this relationship is decreasing at a decreasing rate, meaning as the stage or round number increase, the number of players remaining in the tournament decrease, but at a lesser amount than the previous decrease. Awesome. Taking a look, is this modeled by a linear function? No. The data does not follow a linear pattern. This function is exponential with a growth factor. Remember, exponential means we're multiplying to get to our next output, not adding or subtracting. So this function is exponential with a growth factor. The graph is decreasing at a decreasing rate, not a constant rate of change, which would be your slope. The data is not linear. So if we take a look at our cartridge problem, can number of ink cartridges purchased versus total cost be modeled by a linear function? Yes. And that's because we have a constant rate of change of $25 per ink cartridge. And if we write an equation for that, we have y equals 25x plus 100. Make sure your constant term is at the end and your variable term is in front with your coefficient in front of your variable. And of course, we know that this is linear because it's represented by the equation slope-intercept form, y equals mx plus b. Awesome job, my mini mathematicians. Thank you so much for your hard work and for listening to this video and following along. Please take the remainder of the time to be working on your homework and your review. Have a wonderful rest of your afternoon. Do your best, be nice to everyone, and I will see you upon my return. Video bar out.